So my general background, let's see, I'm computer science by education. I went through grad school there and I taught my way through that, as well as I was basically doing all my research on crypto related topics because that was what was actually interesting in computer science. I did research in basically social recovery was a big thing at the time, as well as decentralized voting were my two big research papers. And out of that, after grad school, I went into like the fintech industry, which was interesting enough. It's fun, but it didn't quite like scratch that itch of like really interesting problems to solve. So I ended up spending all my time after work, essentially researching more into crypto and just looking at different projects, different coins, different ecosystems, and seeing what I thought was actually cool to look into. And after doing a bunch of research, I was like, how has no one started a casino on this technology yet? I was like, that is really weird because we have all these crypto guys that are into meme coins and they're into investing large amounts of money. They're just spending money, throwing it around aimlessly, seemingly. And I was like, someone should have already jumped on this casino trend. Why is no one doing it? So I looked into it and it's like, there's some technical limitations to crypto and blockchain tech, first of all. One, because everything is decentralized and public by that nature. And if you didn't know, actually, random numbers are not as random as we like to think they are. And because of that, they end up being predictable, which proposes a pretty big problem if you wanted to start a casino in the crypto industry. Because if you're playing a game of blackjack and someone can just predict what your hand is, that's not a very fair game. And out of that, I was like, okay, so there's what we call the on-chain randomness problem now. And that was a problem that I saw as interesting enough to kind of ditch my career in fintech and actually come work in crypto to solve this problem. And so after that, I was just looking into how we can solve this problem, and that's how we started RandAO. RandAO, in simple terms, it's really just a way to solve the on-chain randomness problem, where we want to provide random values for any crypto project, any developer, anyone in the world, any business, anyone who wants to start a video game or a casino, lottery, sweepstakes, or some other applications that you could use to that'll basically require unpredictable random values in order to operate. Because if you don't have an unpredictable random value, it's pretty hard to run a casino. So that's really our business prop, is to work with those types of entities who need random values and in essentially a pay-per-value system. We all met in college, interestingly. We were on a computer science intensive living community where actually the first thing we all did together was start an ETH mining rig back in like 2016, 17. And yeah, because like electricity in our college dorm was free. So that was pretty easy to do, and made a little bit of money doing that. And out of that, we just all went through our computer science degrees and started a crypto project together. AO is really just the most interesting chain out there. I looked into a lot of different chains, like EVM or Cosmos or Solana, but AO is just doing it differently. The way they're actually able to offer scalable compute as opposed to fixed throughput is a ridiculous innovation that is insanely undervalued at the moment. And that, when I saw that they could just, when you add a new computer to the network, you actually get more computation power. I was like, wow, who could have thought of this? This is a genius idea. And that's why I was just like, yeah, this is the future, scalable compute. Yeah, so big problem we're solving is what we call the on-chain randomness problem, where if you've ever developed any software, you might realize that random numbers are really pseudo-random numbers, which is they're random. You can't really predict the outcome if you don't know the input, but that's the problem is in blockchain, you do know the input. It's called the seed. And if you actually know the seed to a random function, you end up knowing the final output. And that means you know who wins the lottery, which is a big problem for certain applications. And yeah, so it's really just because blockchains are public and deterministic, we end up with the on-chain randomness problem that we're here to solve. So if you really boil it down, like starting with like Bitcoin is a protocol that pays for SHA-256 hashes. That's all it does. And if you really boil RandAO down, all we do is have a protocol that pays for time lock puzzles. That's really all it does on a technical level. And there's a lot of protocol abstraction on top of that to actually make a time lock puzzle into a random value. And I don't know if I can actually explain this here. I've got an interesting demo. We'll see if this works well on camera or not. But let's see. Live demo, sort of. Okay. So let's say first of all, let's just have one person. Let's say an oracle is to try to generate a random value, and they have some oracle dice. They roll their oracle dice, and we end up with 11. Okay, that's interesting. Now oracle goes ahead and rolls again. That's another 11. Interesting. That's another 11. Can the oracle actually influence the outcome of the random value? That might be a slight problem here. So the question becomes, how can we roll some dice to generate a random value that no one can influence or predict the outcome of? And what we actually end up doing is having a lot of different miners all provide random values. So this is one person mining a random value. They're going to roll their dice. They come out with a 6. And we have another person who comes out with a 4, and another person that comes out with 1. And I can only do so much math, so we end up with, we'll run one more. We will end up with a 12. We have 4 different miners all rolling different dice. These dice end up adding up to a certain number. And in effect, if we wanted to generate either a true or false, a 1 or a 0, you would divide everything by 2. And 12 divided by 2 is 0. And then your coin flip comes out to heads. That's really all we're doing on a protocol level at a very vastly oversimplified protocol level. That's all that really happens, is we roll a bunch of dice, add them all up, and divide by 2. I mean, so one of our first projects that we didn't get off the ground too much, but was an idea we had was to start an on-chain casino. And we were like, oh, it's probably super easy. It's super easy. You can just generate a random value. It's not. You can't just generate a random value. So in essence, we sort of built this protocol because we found a problem in something else we wanted to build. And we realized that that's a problem that a lot of other developers in the blockchain ecosystem are going to have when they want to build their video games, or if they want to build a casino, or if they want to build a lottery, really anything that involves randomness. We realize this is going to be a solution people will have a lot of need for. So the current state of randomness in crypto is there's a few options, right? You can either not use it and just have it be a deterministic, and that works for some things. Not some protocols should be deterministic. I should know what money I get when I do a swap, for instance. You don't particularly need a random number for that. And then there's protocols that would want to use a random value, but don't have a good decentralized option, which means they would go for an Oracle-like solution. And Oracle-like solutions, well put, is they work until it's incentivized for the Oracle to actually rig the game. And for things like a lottery or a casino, or if there's a lot of money on the line for an NFT drop, that is going to be very worthwhile for an Oracle to rig the game. And there's a few other solutions. There's traditional commit reveal schemes, which we're more or less a modified and enhanced commit reveal scheme to solve some of the problems that we saw with those that came out in like 2016, but they had some problems where basically there was a last actor advantage, who the last actor could in effect control the outcome. And we solved that by our new iteration on that protocol. And there's one more, which is effectively using a TEE in order to generate randomness, which like it's similar to the Oracle model. It works until it's incentivized enough for someone to break into the TEE. And as soon as it's easy enough, or it's someone can break into the TEE, the whole random number and all previous random numbers were completely predictable. And that's a serious problem. Random numbers are used all across software, and it'd be hard to name all of them, but I mean, they're used in, sorry, my voice a little bit. They're used in AI for creating initial weights on models. So if you wanted to train a model on chain, it might be appropriate to have a real random number come through. As well as cryptography protocols will have heavy use of random numbers. And if you want to make secure, I'm not sure where this comes in, but I know it's something that would be needed if we have on-chain cryptography going on that needs to be secure. We would need random values in all those protocols. And yeah, like I said, random numbers are used across software, just about everywhere you go. And the ones that are on chain need to be secure. So let's see, We used us for their randomized minting, and Orbi, who I don't think Orbi has quite come out yet, but they are finishing up with their protocol, which will basically generate randomized NFTs on chain. And so that's been our initial use case to get a few different users, as well as Forward Research used us for a sweepstakes protocol. And the sweepstakes protocol is something we're actually building out further because we think it's a great opportunity for a lot of different AO projects to run their own sweepstakes. One of the big ones we think might be very interesting is ARIO. If they wanted to give away a really hot domain name like a X or AR://X or AR:// all the like 3 letters that are super valuable, the ones that they don't give away yet. If they wanted to give away a few of those, that would be a really cool use case of a sweepstakes protocol. So the initial technical challenge was, first making the RandAO protocol in general, because we started with a few different ideas. It's a very hot research topic in the computer science field is how to actually do this. And there's a few sort of theories, and the theory that we built upon was the commit reveal scheme, which works a lot, but there was a small problem with it being the last actor advantage, where so a commit reveal scheme in essence is we have, like I have these dice here, is we have 4 different people that are providing randomness, and we aggregate all their random numbers so that none of them could influence the final outcome. Now, if we have effectively ordered providing of randomness on chain, then the last person to provide their randomness is an interesting state, because they could potentially see everyone else's random numbers on chain. And if you can see everyone else's random numbers and you know what random number you're going to post, you basically have a choice there of what should you post or should you post or not. And based on that, you could either abort the protocol or you could influence the outcome depending on the implementation. The way we solved this is using time lock puzzles as our commitment, where instead of committing a random value, you commit and reveal a random value in the same action. However, the reveal is time delayed. So it's like if you were to say, I'm going to post a random value on chain, and in 10 minutes, everyone is going to know it. But in 10 minutes, I'm probably just going to go ahead and tell everyone what it was beforehand to make it a lot quicker. Something I didn't expect is, I was computer science by education, and that was all my world was technical until like a year ago. It started to become like, oh, we do some of these business aspects that are unexpected. You don't realize that those are important. You have to have a marketing team. You have to have some business development going on. You have to start networking. And as someone who was very in the technical world of we to solve these problems with advanced tech and protocols, that was a very big step to take, and definitely learned a lot of different lessons of, oh, okay, I don't know how to market, got to figure out how to do that really quickly. Need to learn how to network really quickly. Need to learn all these things that you would learn in a business degree that I'd kind of like, take it for guys like, oh, business degrees. But no, business degrees are real. It's a very important field to actually be able to put together all the various pieces of a business and make them all work well together. What you said about opportunity is it's a new chain, which comes with its own challenges of we have to build some of the things that might already be available on other chains, but also that brings opportunity of, oh, okay, there isn't a JavaScript library that is for all of these different processes. And that kind of poses an opportunity, in ETH.js is what would be equivalent on Ethereum that lets you interact with, say, ERC20s. And there isn't a library that would handle that already for you out of the box within AO. And we saw that opportunity of, oh, we can actually create that. We were already going to do it anyway because we needed it. And we can actually offer that to other people, which serves them well because they'll be able to interact with AO tokens of any type. And we'll also be able to get developers around our ecosystem who might be using us for our integrations with AO tokens, but they might also say, hey, RandAO is right here. The integration for that is right next to it. Might as well use that as well. Very welcoming in terms of networking. When we were brought out to ETH Denver, we met so many different people across the ecosystem, from PermaSwap to Bazaar to the Forward Research guys. It was that was a great networking opportunity, and we were glad to have the opportunity to present there and kind of show off how we implement on-chain randomness and it was really a great community for us to tell, because those are all the developers who are going to be using our protocol. So in terms of networking, amazing support. And second, in terms of effectively developer support and getting, there's lots of great documentation, first of all, on how to, I think the actual the AO website or the AO, what is it? AO cookbook. That website has lots of great examples that take you from not an AO developer to a very, very good AO developer very quickly. And there's lots of good videos on how to actually implement different actor-oriented, and bridging that gap of when you're building on ETH, you have a single state of the blockchain at any time. Whereas when you move to AO, it is all asynchronous, similar to web programming more accurately. And that jump from fully synchronous to asynchronous is a large gap to jump, and I'm glad AO has the proper documentation to make that easy. Yeah, so our white paper is fully open source, and that's actually how we get the benefits of being open source, is the way I like to put it, because we had one of our community members actually read our white paper and say, hey, you guys were using verifiable delay functions here, but we could be using time lock puzzles in order to get some extra speed benefits. And that's where open source software is just so powerful, because you get the whole world to basically give you a peer review. The biggest upcoming milestone is we move into our official testnet token. That will be, we have our testnet token that we've been, we give it away. This is nothing, it's no value whatsoever. And then we move into testnet token that there's some airdrop associated with. And that is probably the biggest milestone that's coming up in the next 2 months. And then over the more long term, probably the more, is we have to run testnet for a while and have people use it. So we're going to do a similar concept to how AREO has done their testnet. Is we have a good amount of time where we're making sure everything in the protocol works the way we expect it, get out all the problems before we hit mainnet. So Oracle-based randomness, in essence, what you're doing is you're trusting someone to, one, place a random value on chain when you ask for it. Two, not to manipulate that random value in order to get some form of advantage, like a lottery win. And yeah, that amount of trust in an Oracle is not something I'm particularly willing to put a lot of money on, because as soon as the Oracle's amount of money at stake is below the amount of money that is associated with a lottery win, it's not going to work. And the way we kind of solve that is that we have so many different randomness providers who all have their own amounts of money at stake that they're not allowed to all collude because they're all honeypotting each other. And because of that, we're actually able to have horizontally scaling economic security, that as long as we can add more providers with more at stake, we're able to go up to infinitely large amounts of money that would be secure behind our randomness protocol. In addition, because it's an open protocol, anyone can join the RandAO network. And what's actually very interesting about a protocol is that it's an any honest protocol, meaning as long as one person provides a real random number on the chain that no one else knows, the entire output is random. And if you want to secure your own application, all you have to do is run our software. It's very, and then you can, and that brings your own costs very, very, very low, because you are running your own software and other people know it's random because there are other people being used in, they can also join for one. And as long as you're using at least two and you're one of them, you know that you are having a secure random number being generated. I believe we hit around 46 the other day. I think that was our announcement. And recently we decided we're partnering with RandAO we'll basically bootstrap onto their nodes, where it'll just be a quick flag that you can, if you're already running an RandAO node, all you would need to do is add a quick flag to how you run it, and you automatically get a RandAO node. And that takes us from, I think RandAO has some 300, maybe even more node providers. And that adds all the security we need initially for most any application. Obviously, the more, the better. And it's super easy to do. And as we get more and more actual applications using us, we'll need more and more providers, because we implement, in essence, a two-sided marketplace. Whereas we have more clients on the casino or lottery or video game side, we have more clients there. We'll need more providers in order to meet that demand. And we end up with this marketplace that as it becomes more profitable to run a node, more nodes will run it. And as it becomes, as we need more clients, we get more node providers. To run a node, it's very easy. You can run it on a Raspberry Pi, because generating time lock puzzles is fairly it's low compute, as opposed to mining. You can think of, the way I like to think of it is Bitcoin. You're mining gold. It's hard to find gold, and with RandAO, you're mining. It's like you're mining. It's like you're mining aluminum or something. It's pretty easy to find some aluminum. You can get a lot of it, but we need a lot of it to make a lot of different aluminum cans effectively. So it's easy to mine. You can run it with really just an internet connection and a Raspberry Pi, and it's like run two commands and you're up and running. It's fairly simple. So come mainnet, RNG token is worth real money, because people will pay less than a cent for a random value. And when that happens, you're actually the node provider who provides that bit of randomness or is a part of the generation of randomness is paid a portion of that fee. And in addition, there's also just yield rewards that are paid out to basically subsidize the creation of randomness. And yeah, so those are the two real pieces, is fees and yield.